Namaste children, welcome to Samveda e-learning program. Today we are continuing with the topic electricity. As you can see, this is the third part of the 5 sessions in the topic electricity. Today's subunit is, as you can see, factors on which the resistance of a conductor depends. Children, the previous 2 classes we have learnt basic concepts of electricity and Ohm's law. Now in today's class we are going to learn the factors on which the resistance of a conductor depends on. In today's class, which are the learning points? Yes, here the resistance of the conductor depends on the length of the conductor, area of cross section of the conductor, and the nature of the material of the conductor. Second learning point, electrical resistivity, meaning and its unit. Third learning point, numerical problems based on electrical resistivity. Children, I think you already know that the electric current or electric flow or the flow of charges in any material is different for different materials. As you can see here, if we conduct electric current through a wire, then we will get a free flow of electrical charges. But if the same electric current, if we try to pass it through this eraser which is made of rubber, then what do you think? Will the charges flow through it? Yes, you are right that here the charges won't flow. Come, let's see how the charge flow happens through this activity.
Children, here this is an experiment to verify whether the electric current flows in same quantities in different materials. As you can see, this circuit is open and on the left side you are seeing various types of materials. Now I am taking a coin and inserting it in the circuit, and now if I close the switch, what will happen, children? Yes, as you can see, the charges are moving from minus to plus through the coin. So now the circuit is complete, and this is happening because the coin is a good conductor of electricity, because it is made up of metal which is having huge number of free electrons which pass through the circuit. Now let us verify the same thing for the eraser. What will happen here? Will it allow the charges to pass through it? Let's verify it. Yes, children, what are you observing? Now the switch is closed. Even then the ammeter is showing the reading 0 ampere. That means this eraser is an insulator. So now you are comparing the conductor and an insulator. So this insulator does not have any free electrons. Therefore, even though we provide potential difference, as happens for this paper, the same thing happened for eraser. Just check here. Again we are finding that the current is 0 ampere.
Children, you just saw that in this eraser, when the circuit consisted of this eraser, then the charges did not flow at all, the electrons did not flow at all. So that means this rubber puts a huge amount of resistance to the flow of charges. As you can see, that value is very huge. It is that many ohms, one followed by so many zeros. You can also count them. And also in this example, we saw how this object, when we placed it in a circuit, then the electric charges did not flow or the electrons did not flow. Whereas when we connected this coin, the charges were flowing rapidly, right? So what do we observe here? We observe that charges flow or the electrons flow when there is one type of specific material. What do we call these type of materials where charges flow very easily? Yes, you are right. You answered it correctly. It is a conductor. That means it conducts charges or electrons or electric current. Children, Why do you think the flow of charges is different in different materials? Yes, it is because of the resistance of the material, right. So, as you can see, if it is a conductor, then we can see the charges are flowing very easily, whereas if it is a resistor, then what do you observe here? Here the flow of charges is very less. Can you define what is a conductor and what is a resistor? Yes children, you are right. Come, let us see how can we define a conductor and a resistor. Yes, the conductor is a component of a given size that offers a low resistance, is called as a good conductor, whereas a resistor is a conductor having some appreciable resistance, that is why we call it as a resistor. Children, here what do you observe in this figure? There are three components here. One is conductor, another one is poor conductor, and another one is insulator. Now my question is, what do we call as a insulator? What is an insulator? Yes, you are right. Insulator is a component which does not allow the flow of charges through it. We use these insulators to avoid electric shocks in electric components. So, in these examples, if we take different materials, there is different amount of charges that is flowing through it, right. So, this is what we learned, that what we call as resistance. So, my question is, if the resistance of a material is high, what will be its impact on the flow of electrons? Yes, I think you may have answered it correctly. Come, let us find it out whether what you are thinking is right. Yes children, as you can see, resistance and electric current, they are inversely proportional. If you can see I have mentioned I is current, a symbol used for current, and R is used to denote resistance of a conductor. Here we have taken a good conductor. As you can see, the current is more, electric current is more, whereas the resistance is less. That is why we have shown it in a downward arrow mark. Now, can you make out what is the difference between this insulator and the conductor? Yes, you are perfectly right that in the insulator the resistance is very high, whereas the electric current is less or very negligible. Electric current, electric charges are flowing. So, here we can say that how are resistance and electric current of any material related? Yes, they are inversely proportional. If one is high, the other one is low. So, some materials allow free flow of charges, whereas some materials do not allow such free flow of charges. This is because of the atomic arrangement inside those materials, where the atoms, they absorb, they attract the free flowing electrons more in some substances, whereas in good conductors the free flow of electrons is more. Now children, here is a question. As you can see, these two are wires, wire A and wire B. The question is, if you look at the length, what do you feel here? Yes, the length of wire A is more than the length of wire B, whereas the thickness is same. So, my question is whether these two wires made of same material, having same thickness, but one is longer and the other one is shorter, whether they will be having the same resistance, or whether one will be having higher resistance and the other will be having lower resistance. Is it not interesting? Come, let us find out whether the resistances vary in these two wires.
Children, this is an activity to verify the impact of change in length of the conducting wire on its resistance. As you can see, this L is the length of the conducting wire at the bottom, and now we need to vary the length of this conducting wire and see what happens to its resistance. As you can see, the length of the wire is 10 centimeter and the resistance at the top you can observe 0.667 ohms. So now when we vary the length, my question is, what will happen to the resistance of the conducting wire, whether it will increase or decrease? What do you think, children? Yes, I think you have thought it correctly. Now we need to verify it by varying the length of the conductor. So now from 10 centimeter I am going to increase the length of the conducting wire and observe the variation in the resistance. See, the length is increasing and the resistance at the top, yes, it is increasing. So now the length is 15 centimeter and the resistance, earlier it was 0.667, now the resistance is 1.01 ohm. So what is the reason, children? When we increase the length of the conducting wire, the free electrons need to travel a larger distance, and in traveling larger distances they come across more neighboring atoms which have a force of attraction on the free flow of electrons, and also the electrons collide with neighboring atoms more when they are traveling a larger length. Therefore, when the length of the conducting wire increases, the resistance also increases, as you can see here again. But at the same time, if we decrease the length of the wire, then what may happen to the resistance? Yes, shorter length of wire has a lesser resistance. As you can see, the resistance is 0.2, 0.1, and a larger length of wire has higher resistance.
So children, here as you can see, in wire A, the charges have to travel a longer distance, a longer path. So here number of obstructions or the resistance that the charge will face by in passing through this conductor will be more, because it has to travel more distance, more length it has to travel. So more number of atomic attractions will be there on free electrons, or the electrons will collide with neighboring atoms more. Whereas in this wire it is of shorter length, here the free flow of electrons can be very quick because it has lesser distance to travel. That means lesser amount of attractions by atoms or collision between neighboring atoms happens here. So what we can say that if a wire is of longer length, then the charges need to flow more distance, so they will be having more resistance. That means here we can say the resistance of any conductor is directly proportional to the length of the conductor. That means if the length of the conductor is more, then the resistance is, yes, the resistance of the conductor is also more, even though if they are made of same material. That is why we have mentioned resistance is directly proportional to the length of the conductor. So children, you just saw in this activity that whenever we increase the length of the conductor, the resistance also increases. Now children, what is this? Yes, you already know, it is a rheostat. Why do we use rheostat? Yes, we use rheostat to vary the resistance in the circuit. How do we vary this? If you can see here, there is a wire which is wound around this, and here we choose the two ends through this connector. If we move the connector like this, then what we are doing is we are increasing the length, because if we increase the number of turns, that means we are increasing the length of the wire. So when we slide the rheostat, we are increasing the length of the wire through which the electric current is flowing. That is why by sliding the rheostat, connector in the rheostat, we are varying the resistance in the electrical circuit, because what is the reason? What is varying here? Yes, in rheostat the length of the wire is varying, which results in the variation in the resistance of the conductor or the resistance of the circuit. Children, here is a question. Does the resistance of a conductor depends on its area of cross section? As you can see, these two wires are made of same material, and what about length? Are they same? Yes, the length is also same. What is different in these two wires? Yes, the wire A is thick whereas the wire B is thin. So that means the area of cross section is more. My question is whether if they are made of two same materials, two wires are made of same material, will the resistance vary in this case? What do you think, children? Yes, you are absolutely right. Come, let us see whether what you have thought is right through this activity.
Children, this is an activity to verify the impact of area of cross section on the resistance of a conducting wire. Now, initially we learned that when we vary the length of the conducting wire, the resistance increases with length. Now, what will happen with the area of cross section, that is the thickness of the wire? As you can see, the resistance is 0.667 ohms and the area of cross section is 7.50 centimeters square. So this wire is having a thickness of 7.5 centimeters square. Now just observe the resistance. What is happening to the area of cross section? It is increasing. The wire is becoming thicker or wider, and the resistance which is decreasing, as you can observe, 0.4. It is come around 0.4 ohms. So therefore, when we increase the area of cross section, we are observing that the resistance of the conducting wire is decreasing. As soon as we decrease the area of cross section, we are observing that the resistance of the conducting wire is increasing. The reason is the free flow of electrons have more space when the area of cross section is more, which results in lesser number of collisions and lesser number of attractions, therefore resulting in a lesser resistance. Whereas in a thinner wire, the resistance is very high due to interatomic attractions as well as collisions.
Yes, children, here you just saw the activity. So what can we conclude? Yes, we can conclude that the resistance of a uniform metallic conductor is inversely proportional to the area of cross section. That means R is inversely proportional to 1 by A, or R is proportional to 1 by A, or we can say resistance is inversely proportional to area of cross section. What do you mean by this? Yes, if we increase the area of the conductor, area of cross section of the conductor, the resistance is less. So we can say in these two wires, which wire the electric current is more? Yes, children, you are right. In wire A, it is having bigger area of cross section. So if the area of cross section is more, the resistance will be less. Therefore, here more amount of charges can flow easily. It is some sort of a bigger road and a narrow road situation which we face in our daily lives. If the road is narrow, we will have many obstructions to freely pass through that road. In the same way, it is happening inside the conductors for the flow of electrons. So the answer is wire A, the electric current is more. Two factors we have learned. In which other way does the resistance of a conductor depend on? Yes, in the beginning itself we saw that if we change the materials from metal to rubber in the activity of eraser and coin, there we knew that when we vary the different materials, then the resistance also varies. We verified it. Yes, that is why the resistance of a conductor depends on the nature of the material, what sort of material it is, whether it is a metal or any other substance. So children, here as you can see, R is varying, and when we vary the L, and R is also varying when we vary the area of cross section. But what is not varying even if we vary the length? Just check. Yes, it is the resistivity that is not varying. Even though if we vary the length and area of cross section, the resistivity rho is not varying, right? Are you thinking why? Yes, you are absolutely right. See, this rho is called as resistivity. That means if the value of length, the length of the conductor is 1 unit and the area of cross section is 1 unit, then that object or that material, that conductor will be having a resistance. That resistance is equal to this resistivity. So L should be equal to 1 unit and A should be equal to 1 unit area. So there the resistance will be equal to resistivity. That means I will like to give you one illustration here, one example here. If you take a aluminum wire of 2 meter length and a copper wire of same thickness but of 1 meter length, if you compare those resistivities, then it is very difficult to judge them on a common platform. Why? Both of them are not of same length, right? So that is why we should have unit length and unit area of cross section and then compare copper and aluminum to see which is having more resistance and which is having lesser resistance. This will help us to choose any conductor based on our requirement. So those decisions are made by this one key element called as electrical resistivity, which is denoted by rho, this symbol rho. So what is the electrical resistivity? Resistivity is the electrical resistance of a conductor of unit cross sectional area and unit length. Rho is equal to A into R by L. How did we get this? Rho is equal to A into R by L. Here we have cross multiplied A into R and L we have transposed it to the denominator. So we get rho is equal to A into R by L. And what is the SI unit of electrical resistivity? It is ohm meter. Ohm meter. As you can see, resistance, the unit is ohm, and area and length, they are measured in meters. So we get the unit ohm meter as the SI unit of electrical resistivity. So I just told you that by making note of electrical resistivity of any two conductors, we can take decision which is a better conductor among these two. Now my question to you children is, among copper and iron, which do you think is a better conductor? Yes children, you are right. You will compare the resistivity of copper 1.62 into 10 to the power of minus 8 and resistivity of iron, it is 10 into 10 to the power of minus 8. Which is lesser? Yes, here the resistivity of copper is less. That means in these two, copper and iron, which will have more electric current? Yes, you are right children, it is copper which will allow more electric current to pass through it because it has lesser resistivity. See how we can make these complicated decisions based on this electrical resistivity. Is it not very useful to us to make better electrical appliances and better use of electricity? And children, also if you could look here, these are alloys, and if you look at their electrical resistivity, it is in terms of 10 to the power of minus 6. So my question to you is, in conductors and alloys, which is having more resistivity? Yes, you are right. It is the alloys which are having more resistivity, because here it is only 10 to the power of minus 6, whereas in conductors it was 10 to the power of minus 8. That means it was very less. That is why conductors, they allow more electric current than these alloys. So we can say alloys have a little bit higher resistance than conductor. As you can see, children, here there is a chart showing electrical resistivity of metals and insulators, and also in between there is semiconductors. So conductors and semiconductors have the resistivity in the range of 10 to the power of minus 8 ohm meter to 10 to the power of minus 6 ohm meter, which is very less. That means less resistivity means more electric current, whereas the insulators, they have a very higher electrical resistivity. As you can see, it goes up to 10 to the power of 12 ohm meter, and that is plus x, the power is in plus, here the power is minus. That means we will get a fraction here. Here we will get an exponential number, 1 followed by 12 zeros. Now children, you have learned what is electrical resistivity. Let us try to solve this problem. A conducting wire of length L and area of cross section A has a resistance of 4 ohm. Calculate the resistance of a wire of same material of length L by 2 and area of cross section 2A. So L and A were the length and area of cross section of the wire. Now they have changed the length to L by 2, that means they have half the wire length and they have double the cross section area. Now can we see what will happen to the resistance? Yes, which is the formula that we will use? Come, let us see. Look here children, R is the resistance that we are finding now. Rho L by A is the equation for resistance, and R1 is a new resistance where we have changed the length L by 2 and area of cross section to 2A. So R1 is the new resistance. Now shall we put the values? R1 by R, we will write down the values, is equal to rho L by 2 by 2A. That means here we have noted down R1 value rho L by 2 by 2A, and in below that we have noted down the value of the R, that is rho L by A. Now here we can cancel rho and L as well as A to get the value equal to 1 by 4. As you can see, numerator and denominator both have rho L and A, so both gets cancelled to get 1 by 4. So R1 by R is equal to 1 by 4. So R1 we will write it down, and R we will cross multiply here to R by 4. So that means what is the value of R they had given? Yes, here as you can see, the earlier resistance, the value they had given was 4 ohm. So we can say we are substituting the value of R as 4 ohms. So 4 by 4 is 1. 1 ohm is the new resistance. That means the new resistance of the wire is 1 ohm. Out of today's class, you need to note down these two questions that we have given here and try to solve more questions in the textbook. Mention the factors on which the resistance of a conductor depends. Second question, if a thin wire and a thick wire of same material are connected to a same power source, then in which wire does the current flows easily? Give scientific reason. Okay children, in today's class we have learned about the factors on which the resistance of a conductor depends on, and what is the meaning of electrical resistivity, and also we have solved some problems on electrical resistivity. Now you keep on learning these concepts, you practice more questions at home so that you will understand it more clearly. Thank you very much.